Hi, welcome to venkatvarmachemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. I hope all are doing well. We are here to make JEE and NEET chemistry preparation easier and more effective. Join us for short, easy to understand videos that cover tips and tricks to ease your exams. In this session, I am going to explain alkynes in one shot in 1 hour. Complete alkynes in 1 hour only. This is a revision session. Let's begin our session. Alkynes. See, alkynes, generally, alkynes are unsaturated hydrocarbons. Alkynes are unsaturated hydrocarbons. Unsaturated carbon-carbon triple bonded. See, unsaturated hydrocarbons, carbon-carbon triple bond, carbon-carbon triple bond. See, its general formula CnH2n minus 2. N stands for number of carbon atoms. N stands for number of carbon atoms. See, general name is estalines. General name is acetylene. Its bond length is 1.20 angstroms. Its bond length is 1.20 angstroms. Its functional group, carbon triple bond. Its hybridization, sp hybridization. Alkynes carbon-carbon triple bond, it undergoes sp hybridization. Its shape is linear. Its bond angle is 180 degrees. Its bond energy is 823 kilojoules per mole. See, alkynes exhibit chain isomerism, position isomerism, and functional isomerism. Ci chain isomerism, Pi positional isomerism, Fi functional isomerism. Yes, alkynes are isomers of alkenes, cycloalkenes. This is for general introduction about alkynes. Let's move on. General methods of preparation of alkynes. General methods of preparation of alkynes. The first one is dehydrohalogenation. See, D means removal, hydro means hydrogen, halogenation means halogen. Removal of hydrogen and halogen is a dehydrohalogenation. See, the first one is from vinyl dihalide. See, from vinyl dihalide. What is mean by vinyl? Adjacent carbon atom having the halogen. That is a vinyl dihalide. What type of reagent used? What is the reagent used for the dehydrohalogenation? See, sodamide, NaNH2. Sodamide. NaNH2 and alkalic KOH or alcohol ROH plus sodium alkoxide. This is the reagent used for the dehydrohalogenation. I am taking example. See, for example, carbon with and a halogen and a hydrogen. So halogen with carbon is the alpha carbon, the adjacent carbon is the beta carbon in presence of alkalic KOH. Eliminate the alpha hydrogen and beta hydrogen. What formed? It formed carbon-carbon double bond. Carbon-carbon double bond. Again, it is treated with sodamide, NaNH2. It form alkyne. And one more example, CH3, CHCl and ClH and H, same alkalic KOH. So it is alpha carbon, it is a beta carbon. So chlorine and chlorine of alpha, beta of hydrogen remove, so it form CH3 double bond Cl, CH and H. Again it is treated with NaNH2 to form a CH3 C triple bond CH. It is a propine. This is for vinyl dihalide. From vinyl dihalide. So let's move on. The next one, dehalogenation of tetrahaloalkane. Dehalogen. D means a removal of halogen of tetrahaloalkane by heating of 1, 1, 2, 2 tetrahaloalkane with zinc dust to give alkyne. See, I am writing one example. See, X stands for halogen. In presence of zinc dust. So when it's heated with, so it is 1, 1, 1, 2, 2. 1, 1, 2, 2 tetrahaloalkane heating with zinc dust, it gives alkyne. C triple bond CH plus 2 ZnX2. So very simple. It is a trick to write the product. It's easy to write the product. ZnX2 remove to form a triple bond between carbon. See, I am taking one more example for this. CH3 Cl H in presence of zinc dust is heated. What happened? Very simple. Zinc ZnCl2 to forming CH3C triple bond CH. It is propine and to ZnCl2 This is for dehalogenation of tetrahaloalkane. Yes. Next move on. Next method. Coal-based electrolysis. Next one is a coal-based electrolysis. What is coal-based electrolysis? See, aqueous solution of sodium or potassium salt of carboxylic acid or carboxylic salt electrolysis to give alkyne at anode. See, by electrolysis of aqueous solution of sodium or potassium fumarate or malate electrolysis to gives use acetylene, to use acetylene. Anode, acetylene at anode. See, have a look for example. CH2 double bond CH2 COONA, COONA in presence of aqueous medium, electrolysis to give acetylene, and carbon dioxide. Acetylene at anode, deposited at anode. This is for coal base electrolysis. Have a look for next method. Dehydrogenation. D means remove, hydrogenation means hydrogen. See, dehydrogenation. See, CH2 double bond CH2 with Al2O3, Cr2O3 is heated. Dehydrogenation, it gives alkyne. Ethene with Al2O3, Cr2O3 to give acetylene. This is the dehydrogenation. Have a look for next method. From carbides. Say from carbides, calcium carbides or magnesium carbides. Calcium carbides or magnesium carbide hydrolysis. It gives acetylene and propane. See, I am taking example. Calcium carbide. Calcium carbide means CaC2 hydrolysis. It gives acetylene. See, triple bond. See, magnesium carbide hydrolysis. It gives propane. Calcium carbide hydrolysis to give acetylene. Magnesium carbide hydrolysis, it gives propane. See, CaC2. For example, CaC2, how they are formed? Calcium carbonate. See, CaCO3 decompose to give CaO plus CO2. Yes, in CaO, in presence of carbon, to release calcium carbide and carbon monoxide. See, have a look for example. CaC2 decompose Ca2 plus and C2. You're getting negative charge. CaC2. When calcium ion treated with hydroxide ion to produce calcium hydroxide. Again, it is treated with H plus. In presence of H plus, it gives acetylene. Yes. Have a look for next one. Magnesium carbide decompose. It gives Mg2 plus. And C triple bond C. It has -2 charge. It has -1 charge. It is treated with hydroxyl ion. It forms magnesium hydroxide. When it is treated with H plus, it gives propane CH3 C triple bond CH. This is from carbide. So one more important. See, to prepare 1 mole of acetylene. 1 mole of acetylene. To prepare 1 mole of acetylene, 1 mole of calcium carbonate. 1 mole of calcium carbonate. 3 moles of carbon is required. See, let's move on next method. haloform. From haloform. See, from haloform like chloroform, iodoform. From haloform, chloroform, iodoform. See, iodoform CH3 in presence of silver powder. In presence of silver powder is heated. It forms acetylene. 6 AgI. Yes, pure acetylene is obtained when iodoform or chloroform is heated with silver powder. These are the general methods of preparation of alkynes. Have a look for physical properties of alkyne. Let's move on. Physical properties of alkyne. What are the physical properties of alkyne? See, alkynes are the C2C4 carbon 2 carbon 4 is a gases. They are gases, and C5 to C12 they are liquids. Above carbon 12 is a solids. Alkanes are slightly soluble in water but soluble in carbon tetrachloride, benzene and acid alcohol. So alkynes are soluble in organic solvents. Yes, boiling point and melting points and density of alkynes are comparatively more than alkenes. Melting point, boiling point and density of alkynes are comparatively more than alkenes and alkynes. Alkenes and alkenes due to polarization. Boiling point, melting point densities of alkynes are comparatively more than alkenes and alkenes. It is due to polarization. One more important point. See, boiling point is directly proportional to molecular weight and inversely proportional to number of carbon side chains. Side chains. When boiling point increases with molecular weight increases. Okay, and boiling point decreases with branching increases. Its boiling point decreases. Yes, these are the physical properties of alkynes. Let's move on. Chemical properties of alkyne. See, chemical properties of alkyne. The first one is acidic nature of alkyne. Alkene and alkane. See, in alkyne, carbon undergoes sp hybridization. In alkene, carbon-carbon double bond sp2 hybridization. In alkane, undergoes sp3 hybridization. So sp hybridization is more acidic than sp2 and sp3. Which is more acidic? sp3 carbon is the more acidic. Why? So the electronegativity of carbon sp is greater than carbon sp2 is greater than carbon sp3, which has more electronegativity. sp after that sp2 sp3, it has 50% of the s character. It is nearly 33% of the s character. It is 25% of the s character. Yes, s character. So alkynes are more acidic than alkene and alkene. It is a acidic hydrogen. It is a acidic hydrogen. So it shows what is a acidic nature of alkynes. What is a acidic nature of alkynes? What is the acidic nature of alkane? See, in alkyne, carbon undergoes sp hybridization. It is a acidic hydrogen. Acidic hydrogen in the form of H plus. Here the electrons are moved to carbon. Carbon getting negative charge. It is a acidic hydrogen. Acidic hydrogen. So alkyne shows acidic character. Alkyne shows acidic character. Yes. Now reaction with metal, sodium metal. Reaction with sodium metal. So alkynes, carbon triple bond C with acidic hydrogen in presence of sodium metal is heated. So R C triple bond C Ne. Yes. Carbon getting negative charge, sodium getting positive charge. It produces H2 gas, half H2 gas. Again, I am taking one more example. H, C, triple bond C, H in presence of sodium metal is heated. It having the two acidic hydrogen to form a C triple bond C minus and Na plus to produce H2 gas. This is the reaction with sodium with alkyne. Sodium with alkyne. Have a look for next reaction. Have a look for sodamide. Reaction with sodamide. NaNH2. See, NaNH2. See, I am writing reaction. Alkyne. R C triple bond C H. You are getting negative charge. Yes. And it is treated with NaNH2. NH2 minus Na plus NH2 minus. So here R C triple bond C Na plus. Yes. And to produce ammonia gas. Have a look for next example. H C triple bond C in presence of NaNH2 or Na plus NH2 minus. See, this is a carbon triple bonded with Na plus to produce 2 moles of ammonia. To produce the two acidic hydrogens are present, it produces 2 moles of ammonia. Yes. This is the reaction with NaNH2, sodamide. It is the reaction with sodamide. Have a look for next reaction. Addition reaction. See, hydrogenation. What it means? Hydrogenation. Addition of hydrogen is a hydrogenation. See, I am writing hydrogenation. In hydrogenation, addition. See, C triple bond C with H adding H2 gas in presence of nickel metal it gives CH3. Addition of hydrogen in presence of nickel or platinum metal to produce alkenes. Have a look for one more example. It is a 2-butane. It is a 2-butane. In 2-butane addition with linear catalyst palladium barium sulfate and in presence of liquid or sodium liquid ammonia. Yes. So when linear catalyst is used to form a syn addition, means cis alkene is produced. It gives cis alkene, carbon double bonded with hydrogens are attached with same side. It is a cis alkene. Yes. In liquid ammonia, it is a Birch reduction. At carbon-carbon, the hydrogens are attacked in opposite side. Opposite side, it is a trans-alkene. It gives trans-alkene. Addition of hydrogen in presence of nickel or platinum metal to give alkene. Alkynes 2-butane hydrogen gas in presence of Lindlar catalyst. It gives cis-alkene. Birch reduction, it gives trans-alkene. Trans-alkene. See, have a look for next reaction. Addition of hydrogen and a halogen. Addition of hydrogen and halogen. So write the reaction. C R C triple bond C H in presence of hydrogen and halogen H plus X minus in presence of, you're getting negative charge, you're getting negative charge. Yes, sorry, you're getting positive charge. So R group is a plus inductive effect group. So the pi bond is shifted to this side, you're getting negative charge, you're getting partial positive charge. In this R sorry H, that is a X. It form gem dihalide. It form gem dihalide. Yes, I am taking one more example. Carbon triple bond with H in presence of two equivalent hydrogen bromide, means 2 moles of hydrogen bromide. What is a product? What is a product? See, the pi bond is shifted to carbon. You're getting partial positive charge, partial negative charge. Yes. See, this is our product. This is for addition of hydrogen halide. Have a look for next reaction. Addition of X2 in carbon tetrachloride. Addition of halogen in carbon tetrachloride. See, I am writing an example. R C triple bond C H in presence of X2 in carbon tetrachloride. So breaking of pi bonds, keeping of halogen, So I am writing C X X X and H. Simply breaking of pi bond, keeping of halogen. It is a tetrahalide. It is a tetrahalide. Yes, I am writing one example. See, in presence of 2Cl2 in carbon tetrachloride. Simply breaking of pi bonds, keeping of halogen or keeping of chlorine. Yes, I am writing product. So, tetrachloride to form a tetrachloride. This is for addition of X2 in carbon tetrachloride. Yes, let's move on next reaction. Addition of water in presence of Hg2 plus mercuric ion. Addition of H2 in Hg2 plus mercuric sulfate in dilute sulfuric acid. It is a Kucherov reaction. It is a Kucherov reaction. See, first of all, I am writing R C triple bond C H in presence of Hg2 plus in H plus. So 2H plus and OH minus. Yes, presence of H2O. So what is a product? It form C OH and H. Carbon having 2 OH group, it is unstable. It remove the water minus H2O to form a RC double bond CH3. It gives ketones. Ketone is generally acetylene hydration to give aldehydes. Is alkynes hydration. Alkyne hydration, it gives ketones. Remember, acetylene hydration to give aldehyde and alkynes hydration it gives ketones. Have a look for one more example for this reaction. See, CH3 C triple bond C H in presence of Hg2 plus H2O and 2H plus OH minus. Very simple. CH3C OH. Yes, it form minus H2O. It gives CH3 C double bond O CH3. It is a ketone. C double bond O CH3. Ketones are formed. So I'm writing one more example. If benzene with C triple bond CH in presence of Hg2 plus H2O in 2H plus and OH minus, what is the product? See, have a look for example. Minus H2O benzene with COCH3. This is the product. Addition of H2O, Hg2 plus and 2H plus and hydroxyl. See, have a look for next reaction. Addition of hypohalate HOX. Hypohalate. See, alkyne C triple bond CH in presence of hypohalate HOCl. Hypohalate. Yes, see, HOCl. It form Cl means chlorine with CH C double bond O H. Pi bond is shifted. You are getting partial positive charge, partial negative charge. Yes, it is plus charge. It is a minus charge. HO minus Cl plus. Yes, it forms 2 moles. The 2 chlorines attached with the positive charge. Negative charge. Opposite charges are attracted. Same charges are repelled. Yes, again CH3 C triple bond C H in presence of 2 HOCl. You are getting partial positive charge, partial negative charge. It forms CH3 C double bond O Cl H. This is the addition of hypohalate with alkynes. We can move the next reaction. Addition of borane or diborane in tetrahydrofuran B2H6. Hydroboration with alkyne C triple bond CH in presence of BH3 diborane in presence of acetic acid CH3 COOH, it CH double bond CH, H and H. Yes, again in presence of hydrogen peroxide H2O2, it gives CH double bond CH OH, it form CH3C double bond H. Diborane or hydroboration. See, alkyne with diborane in presence of hydrogen peroxide H2O2, it form enol with it form CH3CH2 C double bond H. Yes, next I will look for next example. In presence of BH3 diborane in presence of hydrogen peroxide, it form CH2CHO. Again, butane in presence of diborane and CH3COOK. Acid. What is the product? It gives carbon-carbon double bond. It gives cis-2-butene. Next. With sorry. See. Butane with diborane in presence of hydrogen peroxide. It gives what? Ketones. It gives ketones. Next. Cycloheptine in presence of diborane in presence of hydrogen peroxide. It gives, this is a product. One more important point, see, terminal alkynes gives aldehydes. Terminal alkynes are gives aldehydes with BH3 in presence of hydrogen peroxide H2O2. Next, internal alkynes gives ketones with diborane in presence of hydrogen peroxide. So terminal alkanes are gives aldehyde, internal alkanes gives ketones. Let's move on. Next reaction. Addition of ozone. Next is the addition of ozone. See, addition of ozone. Alkynes ozonolysis. See, alkynes ozonolysis. Alkynes ozonolysis to gives carboxylic acids. Carboxylic acid. For example, acetylene, C triple bond C H in presence of ozone O3, it gives in presence of zinc reduction, it gives HCOOH. COOH. Again, or C triple bond C, or in presence of ozone C. In presence of zinc reduction, zinc with water, it gives 2 RCOOH, carboxylic acid. Carboxylic acid. Alkyne ozonolysis to give carboxylic acid. Look at for one more example. See, it is a 2-butane in presence of ozone, zinc with water. What is the product? Breaking CH3 COOH. CH3 COOH. 2 moles of acetic acid is formed. 2 moles of acetic acid is formed. Again, 1, 2, 3, 4, 5. 2-pentyne. It is a 2-butane. Ozone, zinc reduction with zinc in H2O. What is the product? You are breaking CH3COOH, CH3CH2COOH. Breaking and keeping of OH. See, first one CH3COOH. Again this part CH3CH2COOH. CH3CH2COOH. I am writing one more example. Cyclohexane in presence of zinc reduction with zinc in water. What is the product? COOH and COOH. Breaking keeping of OH. Yes. Next reaction is a reaction with the cold KMnO4. Reaction with cold KMnO4 solution, cold dilute KMnO4 solution. See, alkyne with cold KMnO4 solution. Cold KMnO4 solution. It forms C double bond O, C double bond O. Keeping of oxygen. Yes, next, or C triple bond C H in presence of cold KMnO4. Cold KMnO4 to form R C double bond O, C double bond H. Again, R C triple bond C, or in presence of cold KMnO4 solution. Cold KMnO4 solution, or C double bond O, C double bond R, C double bond O R. Next reaction, CH3 C triple bond C, CH3 in presence of cold KMnO4 solution. It gives CH3 C double bond O, C double bond O, CH3. This is the reaction with cold KMnO4 solution. Next with the hot KMnO4. Reaction with the hot KMnO4 or acidified KMnO4. Acidified KMnO4. hot KMnO4 or acidified KMnO4. See, alkyne C triple bond CH in presence of KMnO4 in presence of H plus. H plus means acid medium to produce carbon dioxide, or C triple bond CH in presence of KMnO4 H plus. It gives RCOOH plus CO2. Again RC triple bond CR KMnO4 in presence of acidic medium. It gives 2 moles of carboxylic acid. Yes, next CH3 C triple bond C CH3 in presence of KMnO4 in acid medium to give CH3 COOH. Yes, this is in presence of hot KMnO4 or acidified potassium permanganate with alkyne. Have a look for next reaction. Oxidation with selenium dioxide SeO2. See, HC triple bond CH in presence of selenium dioxide SeO2. SeO2. It is similar with cold KMnO4. It is similar with cold KMnO4. Very simple. H C double bond O C double bond O H, or C triple bond C H in presence of selenium dioxide. It form R C double bond O C double bond H. Yes. Next R C triple bond C R in presence of selenium dioxide, R C double bond O C double bond O R. This is the oxidation with the selenium dioxide. Oxidation with the selenium dioxide. Next reaction with the arsenic chloride. Arsenic chloride alkyne C triple bond H C triple bond CH, arsenic chloride AsCl3. It gives Lewisite CH double bond CH. It is Cl. It is AsCl2. It is a Lewisite. Lewisite. Yes. Next, addition of acetic acid. Addition of acetic acid with alkyne. H C triple bond CH in presence of acetic acid CH3 COOH. What is the product? It gives CH3 C double bond O OCH double bond CH2. Next reaction, carboxylation and isomerization. First one, carboxylation. Carboxylation means alkyne with carbon monoxide with water. Carbon monoxide with water, nickel tetracarbonyl to give acrylic acid CH2 double bond CHCOOH. It is a acrylic acid. Yes. Next, isomerization. I will look for isomerization. 1-butene in presence of alkalic KOH NaNH2 sodamide. It gives 2-butene. 1-butene to 2-butene. 1-butene to 2-butene. Isomerization in presence of alkalic KOH NaNH2. I will look for next reaction. Polymerization reaction. In polymerization reaction, the first one is coupling reaction. Coupling reaction. 3 moles of acetylene in presence of red hot tube. It gives benzene. Polymerization reaction. It is a trimerization. Reaction. Trimerization reaction. Yes. See, CH triple bond CH, yes. CH triple bond CH, yes. CH triple bond CH. So this bond is shifted to this side. Here getting partial negative charge, partial positive charge. Here getting partial positive charge, partial negative charge. Here getting partial positive charge, partial negative charge. So the bond is shifted here to form a benzene. To form a benzene, it is a coupling reaction. Coupling reaction. Have a look for one more example for this. See, CH3, C triple bond CH. It is a propine. 3 moles of propine in presence of red hot tube. Red hot tube. It gives mesitylene. It gives mesitylene. Mesitylene. Yes. Again 2-butane. CH3, C triple bond C, CH3 in presence of red hot tube. It gives hexamethylene benzene. It gives hexamethylene benzene. Hexamethylene benzene. Hexamethylene benzene. Yes, next CH triple bond CH in presence of nickel cyanide. In presence of nickel cyanide, DMF, dimethyl formamide, it gives cycloocta tetraene. Cycloocta tetraene, it is a non-aromatic and it like tub-like shape. Tub-like shape. Yes, these are the coupling reactions. Next one is linear coupling. Linear coupling reaction. See, 2 moles of acetylene in presence of CH2Cl2 methylene chloride in presence of ammonium chloride. It gives vinyl acetylene CH2CH C triple bond H, vinyl acetylene. Vinyl acetylene. Yes. Next is the oxidative coupling reaction. Next is the oxidative coupling reaction. What is oxidative coupling reaction? See, or C triple bond CH in presence of Cu, copper, Cu, oxidation, it gives R C triple bond C, C triple bond C R. Yes, next, how they are formed? R C triple bond C, Cu plus O2 Cu, C triple bond C R. This is the oxidative coupling reaction. Oxidative coupling reaction. Next one more reaction. Test for terminal alkane. Terminal alkanes are identified the tolerance test. What is tolerance test? See, alkyne or C triple bond C H with silver nitrate AgNO3 in presence of ammonium hydroxide. Ammonium hydroxide, it gives RC triple bond C Ag plus. It gives white precipitation. White precipitation. This is a tolerance test. Silver nitrate with ammonium hydroxide. It gives white precipitation with acetylene or alkyne. Next, cuprous chloride test. Cuprous chloride test. See, again RC triple bond C with what is the reagent? Cuprous chloride. Cu2Cl2. Cu2Cl2. It gives RC triple bond C and Cu. It gives red precipitation. It gives red precipitation. Cuprous chloride test. Yes. Next. Separation of ethene, ethyne. See, separation of ethene, C2H6, C2H4 and C2H2. How to separate them? When this solution is passing through ammonical cuprous chloride solution. See, passing the ammonical cuprous chloride solution. When acetylene, it gives red precipitation. Yes, red precipitation, red PPT with a Cu, C triple bond Cu. Yes. Next, the second one is gaseous mixture. This gaseous mixture has C2H4 and C2H6. See this red precipitation with the potassium cyanide, it gives ethine. We can separate the ethane. So the gaseous mixture contain ethane and ethene. It is passing with concentrated sulfuric acid. It gives, first one is ethyl sulfate is given. And it gives ethene gas. The ethyl sulfate, when is heated, it gives ethene. So we can separate ethene and ethane gas. This is the separation of ethane and acetylene. Separation of ethane and ethane. This is a complete lecture of alkynes in 1 hour. Yes. I hope like this video. Don't forget to share your friends. Don't forget to give like. If you find this content is valuable, make sure to subscribe our channel. Hit the bell icon to stay updated with latest videos. Thanks for watching.